All right, welcome to part 6. This is questions 51 through 54. We're going to finish up practice exam 4. So 51 says, in a survey 774 employees of a large company, 26% said they had high job satisfaction. We want to find the 95th percent confidence interval for the true population proportion. All right, so we have 774 polled. So I'm going to find the margin of error, which is done by 1 divided by the square root of 774. 1 divided by the square root of 774 is going to give us 0.0359. So we can say it's 0.036 is going to be our margin of error, or 3.6%. So what we're going to do is take 26% and add 3.6 to get 29.6. and subtract a 3.6 to get 22.7. So right there is our confidence interval, 22.7. I'm sorry, 3.6 should be 22.4. It's because then when you add 3.6, it'll get up to there. So that I didn't see 22.7 up here, but 22.4 is there. And so that makes C our correct answer. Next question is 52. Suppose you're watching television newscasts in which the reporter mentions that the president's approval rating is estimated to be about 52% using a random sample of 809 surveyed adults in the country. Nothing is mentioned about the margin of error, but you know that you can calculate the confidence interval based upon those two simple statistics. We want to know what the approximate lower bound of the 95th confidence interval for the president's approval rating would be. So what you want to do is we're going to be looking for the 95th percentile, so we go 1 over the square root of n. The sample size in this case was 809, so that's how many people took the survey. And that is going to give us the margin of error. So we come over here, 809, actually let's go 1 divided by 809 square root. And we're going to find that that is 0.035 roughly, or 3.5%. We're looking for the lower bound. Remember that 52% of the sample size said that they approved. So now we're going to subtract that 3.5 to find our lower bound. And in this case, 48.5 is that lower bound. If you want to find the upper bound, you'd add it and you get 55.5. But that's not necessary in this case because 48.5 is sufficient to say that's what my lower bound of the confidence scale would be. What does it mean for to be observed difference to be statistically significant to the 0.05 level, or 95% confidence level? We want to assume the null hypothesis is true. All right, because of that, the probability of the observed difference occurring by a chance is, notice now we're looking at the difference. Now 0.05, you can quickly eliminate A and C. Now is it 5 in 100 or less, or 5 in 100 or more? Now remember, the confidence is that it's going to be that chance or less at that confidence level. So in this case, B would be the correct answer. That's a chance of 5 in 100 or less. And that's why we like it, because if it was or more, it wouldn't necessarily have the same power. 54. A local statistics professor wants to replicate a University of Maryland study that was conducted on the issue of healthy adult body temperatures. For many decades, the healthy adult body temperature has been assumed to be 98.6 degrees Fahrenheit, which is our null hypothesis. To focus on the objective benchmark prior to the data gathering, a significance level of 0.01 is selected for this study. So we're looking for a 99% confidence level. The professor finds that through her study using a random sample of 100 healthy adult participants that the sample mean was 98.3. She determined that given the null hypothesis was true, the probability of getting a sample mean of 98.3 or lower is less than 1 in a million. Okay? Which of the following is correct? There is not enough evidence to suggest that the sample mean is significantly different than the assumed mean of 98.6, and therefore the null hypothesis cannot be rejected. Okay? Actually, if you look at that, the difference, there is enough to say that there's a little bit of a difference. Okay? there is enough evidence to say that they're significantly. In fact, B kind of is hitting that. There is enough evidence to suggest that the sample mean is significantly different than the assumed mean of 98.6. 0.3 degrees in body temperature is quite evident, and therefore the null hypothesis can be rejected. Because we have enough data on that, then you could say, yes, I can reject the null hypothesis in this case, which means because we reject the null hypothesis, we can't come to a conclusion. That's what that means. So B is the correct answer, at least in my opinion. We can verify by looking at the last term. There's not large enough sample size to draw any proper conclusions regarding the null hypothesis. In that case, that's not necessary. The probability of getting the sample mean, or even lower than that, is less than 0.1. Okay, so there, with 100 people, there is a probability. There's enough evidence to suggest that that sample mean is significantly different, and therefore you can reject that. Okay. All right. Good luck. If you have any further questions about this, please be sure to email me or let me know. Good luck on your tests.